particle on a sphere. We're going to add in that third and final dimension, and that's going to really help us continue to explore the uncertainty principle associated with this stuff. Okay? So, I'll remind you, our particle on a ring was rotating perfectly in and out of the xy plane with angular momentum pointing in the z direction. If we want to expand this to become a three-dimensional model, it really becomes a particle on a sphere. And now what that means is my rotation axis now is free to pitch in and out of either the zy plane, right? I can keep rotating it like this, or it can pitch into the zx plane, right? Like this. And so the result of that, you can see the sphere that we have is now we have to consider the angle theta that describes how this rotation plane pitches either in either the the zy or the zx dimension. Okay? So here's what we need to do. Cry, pray, guess, solve, right? You are on top of that. Okay? So maybe you're crying and praying right now. We're going to guess and solve soon. And the reason why you might be crying and praying now is because this math gets kind of nasty. So here we have del squared, but in 3 dimensions, right? So we're still dealing with zero potential energy. We're still dealing with our translational kinetic energy operator, but now we've added that z dimension, okay? So through standard manipulation, I'll just say standard, this del squared in spherical coordinates becomes the following, right? All of our second derivatives in R. Okay, make sure that I'm on the right track here. Yep. And now what we have, this new complication, is the appearance of this seemingly innocent little guy called the Legendrin. And the Legendrin is not our friend. This is the equation. 1 over sine squared theta, second derivative in phi, plus 1 over sine theta, first derivative in phi, times sine of theta, first derivative in theta. So this is going to get nasty. So is there any simplifications that we can make? Well, yes. We remember that we have a constant radius, right? So that means all of these terms involving derivatives can go away. And now what we get is our del squared is going to be 1 over r squared times the Legendrin squared. And so now our kinetic energy operator becomes negative h bar squared divided by 2m r squared that comes from right there, okay, times the Legendrin squared, and that all becomes negative h bar squared divided by 2i times the Legendrin, okay? And so this seems fairly innocent, right? When I put together, here is my Schrödinger equation. It doesn't look so terrible, but remember, this Legendrin, right, is intense, okay? So we're going to have to deal with it. So finish crying and praying about the Legendrin.